Hello dear friends, welcome to Gate Academy Global. So before starting today's video, I would like to take the concurrence from each one of you, the quality of video as well as audio. Is it perfect or not? If it is perfect, just give a thumbs up over the chat box. And from today onwards, or probably in today's video, we are going to discuss about the convergence test of the infinite series. And as far as this topic is concerned, it's a very important topic in all of the branch, whether you are from civil, mechanical, electrical, electronics, instrumentation, because the question have been keep coming from this topic, whether it has been written in your syllabus or not, but still the questions are keep coming. So you can say it's one of the very important topic. So tell me the quality of audio and video, is it perfect or not? If it is perfect, just write perfect over the chat box. Just write the perfect over the chat box. Then I'll get to know that everything is perfect. Tell me, everything is okay? Okay, then let me see once again. Nobody is replying, so let me check it out whether everything is fine or not. Probably everything is fine. Okay, so infinite series, as far as this topic is concerned, I am going to bifurcate this topic in 4 to 5 different number of subparts. At very beginning, I would be discussing about the definition of the infinite series. At very beginning, I'll be talking a little bit about the sequence, and from the sequence, I'll try to get how the series can be formed from a given sequence. So anyways, at very beginning, we are going to discuss about the definition of the infinite series. Yes. Now, secondly, I would be moving into the classification of the infinite series. Everybody should write each and everything in their copies. Classification of the infinite series. As far as the infinite series is concerned, or the classification of the infinite series is concerned, the infinite series can be bifurcated in the two parts. The first part is going to be positive term series, and second term is going to be, or second classification is going to be, first is going to be positive term series, and second is going to be alternating series. Agreed? Now, in third point we are going to discuss about what are the different outcomes we can get once we are solving or once we are dealing with the infinite series. See, the complete series may get converged to a certain fixed finite value. In that case, the series would be called as a convergence series, and similarly, the complete sum of the series may be going to plus infinity or minus infinity. In that case, the series is called a divergence series, or sometime what happens, the output is neither fixed to a particular finite value. It is oscillating between the two values. In that case, the output is said to be oscillatory. So we would be talking about the different kinds of infinite series you have. So here the first kind would be divergence series. You can have convergence series, and even at the worst of the worst condition, you can have oscillatory series. Agreed? And once this three part is getting over, we are going to take few of the design problem which I have designed, and there we will be taking the practice problems, and we will also be taking few of the questions which have come earlier in gate examination. Is that part clear to all of us? I repeat, I am starting the infinite series, and the infinite series is going to be over in today's video itself. As far as the infinite series is concerned, basically I have bifurcated into the 4 different sub-modules. At very beginning, we are going to discuss about the definition of the infinite series. Once the definition would be over, we will be bifurcating the infinite series in the 2 different classes. First class is going to be positive term, and second class is going to be alternating infinite series. And keep in mind, as far as the infinite series is concerned, you would be facing either the positive term series or you would be facing an alternating series. There is no other way apart from this classification. Now, once we have an infinite series, after summing them up, if you reaches to a certain finite value, then we find the result is said to be convergent in nature. If we are adding them all up together, and if the result was found somewhere plus infinity or minus infinity, in that case, that infinite series is said to be divergent in nature. And sometime it has been seen, once we add all of the datas together, neither we are reaching plus infinity, minus infinity, neither we are reaching to a fixed finite value. In that case, I say my infinite series is oscillatory in nature. And anyways, end of the day, we are going to take few number of practice problems and as well as the problem which have appeared in GATE examination. Yes, agreed what I am saying? I will show you few more things like this problem. This problem have come in GATE, civil engineering, electrical, electronics, instrumentation, probably in all of the branches. Only I have written CA, but yes, this problem have come in 4 different branches in 4 different years. The problem is the infinite series 1 plus 1 by 2 plus 1 by 3 plus. This series goes on, and after adding all of the terms within the series, the result, would it be convergent, would it be divergent, would it be oscillatory, or would it be unstable? Anyways, until and unless you are not going through my video completely, you would not be able to conclude anything. Similarly, in the same sequence, I have designed one problem. See, this sort of problem may come. Like earlier you had 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Instead the 1 plus 1 by 2, now it's root 2, root 3, root 4, root 5. Again I need to take the result out of it, which type of series it is. Yes. Similarly this. And this sort of problem have come many of the times. Like this problem have come in civil engineering. Once the problem have also come from electrical engineering. So this sort of problems are very important problem. We'll see how we'll address this sort of problem. The infinite series, n is starting from 1 going till infinity, factorial of n square divided by 2n factorial, would it be what? Yes. And similarly here goes my 6th question. This question have come, you can see over your board, this question have come in instrumentation, and probably 6 or 7 number of questions we are going to take. Yes, 7th question, it has come in agriculture. Deliberately I have taken one problem from the agriculture such that you guys would have good bundle of questions from where you can infer few of the good concepts. Will it be convergent? Okay, we'll see that. Anyways, let me come back to my working board. So first go ahead with the definition. So everybody should write in their copy definition of series. So the heading goes like definition of series. Definition of series. Yes. But before going into the detailed analysis of the definition of series, let me start with sequence. So within the series, let me start with a sequence. So the first important word which you might be encountering many of the times in mathematics, and even it is there in your syllabus, it's nothing but sequence. Write down sequence. So you can write a brief definition regarding the sequence. Write down. Sequence is a mathematical representation of real numbers separated by commas. Like, let me take few number of examples. The first example could be like 1, then 2, then 3, then 4, then 5, so on and so forth. May I know what would be the nth term? First term is 1, second term is 2, third term is 3. So nth term would be n, and it may go on. Yes. Similarly, you can have examples like 1 upon 1, then 1 upon 4, then 1 upon 9, then 1 upon 16. May I know what would be the nth term? See, you can see very well. In the first term, it was 1. In second term, it was 4. That means 2 to the power of 3. In third term, it was 9. That means 3 to the power of 2. In fourth term, it was 16. That means 4 to the power of 2. So in nth term, it would be 1 upon n square. and it may go on. It may go on. Yes. So may I know what is n? It's the nth term. Nth term, and similarly 1 upon n square is also the nth term. Nth term. Yes. From here onwards, the nth term would be referred in standard by a suffix n. Keep in mind, in sequence, nth term is referred by a suffix n. Even you might have seen this in arithmetic progression. We used to calculate the nth term in arithmetic progression and we write it a suffix n. Even the arithmetic progression is also a type of sequence. Is also a type of sequence. Yes. Could you understand what I am saying? Yes. So here in sequence the nth term is referred by a of n. So in this sequence, n is nothing but the nth term, and similarly in this sequence nth term is nothing but 1 upon n square. So in future, rather writing the each and individual numbers in terms of their commas, I can just refer by the value of a of n. Why? Because in future you can keep the value of n. The value of n would start always from 1. This is my first sequence, then the second data in the sequence, third data in the sequence. Similarly, it's my first data in the sequence, second data in the sequence, third data in the sequence. Just by feeding n is equals to 1, I will be getting the first data. Just by feeding n is equals to 2, I would be getting the second data, and just getting feed by 3, I would be getting the third data. Yes, could you understand what I am saying? So one thing should be clear in your mind. Whenever I talk about the sequence, the real numbers are distincted, or real numbers have been separated using the commas. That's the first thing. And keep in mind, n cannot be 0, or n cannot be 1.5, or n cannot be 3 divided by 5. Keep in mind, n would always be a natural number. Whenever we talk about the a suffix n, no, n would always be a natural number. You can't say, sir, this is my 0th term. You can't say, sir, it is my 3 by 2/8 term. So if we talk about their numbering, obviously they had to be a natural number. So as far as the sequence is concerned, where the real numbers are separated using the commas, the first place would be the first number, second place would be the second number, or I can say it's a suffix 2, it's a suffix 3 number, it's a suffix 4, so on and so forth. Yes. Or in total, in future, wherever I would be referring the sequence, I would just be giving like an is equals to of n divided by of 1 plus n square. That's adequate, rather giving the complete number itself. You can see, you can feed the value of n as 1, you will be getting the first data. May I know what would be that first data? That would be 1 divided by 2. Similarly, what would be the second data? The second data, the 2 has to be fed over here, it's going to be 2 divided by 5. May I know what would be the third data? The 3 has to be fed. Instead the n, it would become 3 divided by of 10, and it will go on. What would be the nth data? The nth data is clearly given to you, and it may keep go on. Yes. Till this point, just a minute. Till this point, each and everything must be clear to all of us. But. As far as today's topic is concerned, we are focusing over the series. And the series is going to be manufactured by the sequence. And as we have infinite series, the series is nothing but the sum of the all possible values over the sequences. Like. Once we have started adding them together, so this complete sequence would result a series. So may I know what is a series? The series is the sum of the number present into the sequence. May I know how many terms or how many numbers have been present into your sequence? N. And even you can go to the n plus 1, n plus 2, and in total, if the number of terms present in sequence is infinity, that sequence would become infinite sequence. You can write one thing, because with the help of infinite sequence, we are going to manufacture infinite series in future. Write down. Infinite sequence. A sequence which contains infinite number of terms. That means n can go towards infinity. N can go towards infinity. Yes. Till this point, each and everything must be clear to all of us. Yes. Now let me go ahead with the next page. Now I shall be talking about the series. And as far as the series is concerned, my basic focus is at infinite series. So may I know what would be the definition of it? The definition is self-explanatory. What it is? The series is the sum of the infinite sequence. Write down. Series is the sum of infinite sequence. That means a sequence having infinite number of terms. Infinite sequence. Infinite sequence. That would be the definition of infinite series. Next. Infinite series can be represented in two different ways. The infinite series can be represented in two different ways. See, either I write this as S of n. The S stands for, keep in mind, S stands for sum, n stands for the starting nth term, S of n, or it can also be written as discrete sum of A of n. It's a two different way to represent. Your series. What does that mean of it? That means the numbers within the sequence is getting added. Is this the first class? Obviously it's the first class, and within this class the sequence as well as series is getting over, and which is very important in your gate examination. And now may I know when it would be an infinite series and when it would be a finite series? I don't have to talk about the finite series, I just focus over the infinite series. So may I know from where the n would start? The n would start from 0, n would start from 4 till the infinite term. Agreed what I am saying? Now let me take few number of examples. Just a minute. So let me take few number of examples. Like we had the sequence in last page. What it was? 1, 2, 3, 4, 5, 6, 7. Nth term was n. Then n plus 1, n plus 2. If they have been added together, 3, the nth term would be n, and thereafter the number of terms it has been clearly given would be infinity. So if you are adding all of the numbers together till the last term, which is the infinite term, by default it becomes a infinite series. And even if you want, you can write this infinite series as, see, the first number is nothing but n, the second number is nothing but 2, the third number is nothing but 3. So may I know how it can be written? This can be written as discrete sum of n, where the n goes from 1 to infinity. As I have communicated earlier, even it can be written in terms of the discrete sum of the nth term. So here it becomes n is equals to 1 goes till infinity, and simply it's a just n. Is that part clear? Till this point, each and everything must be clear to all of us. We should not have any doubt till this point. Similarly, you can have the another example. You can take the example number 2. If I write a series where the n starts from 1 and goes till infinity, let's take the series is minus 1 to the power of n divided by of 2 to the power of n. Again, it's gonna be a series. May I know how the expansion would be? The first term, where the value of n would be 1 minus 1 to the power of minus, that's gonna be minus, and here it becomes 1 divided by 2. Thereafter it goes as plus. Here minus 1 to the power of 2, because now we have situated at the second term, it would become plus divided by of 4. The next term would be minus divided by of 8. Similarly, plus 1 divided by 16, and it would go till the infinite term. Again, it would become your infinite series. So infinite series can be represented in two different ways. Either straight away they might have been given the sum of the sequences, or they might have given the discrete sum of its nth term. You can see very well what's going to be its nth term. The nth term is same, which we have wrote somewhere here. It's going to be this. Yes, would you agree? So may I know one thing? Let me go down. So few of the questions which I have shown over the digital board like this, whether it's an infinite series or not. Obviously it's an infinite series. May I know what's going to be its nth term? If you want, you can write its nth term here itself. Its nth term, the first term is 1 by 1, the second term is 1 by 2, third term is 1 by 3. So may I know what would be its nth term? The nth term would be 1 by n, and anyways still it is an infinite series, and we wanted to know which type of behavior this problem shows. Anyways, come back. Now if I come to this situation, may I know what would be its nth term? The first term is 1 divided by root 1, second term is 1 divided by root 2, third term is 1 divided by root 3. So obviously the nth term would be 1 divided by root n, and it is again an infinite series. Yes, and even if I come down, see, this is another way to represent the same infinite series. What it is? See, if you will keep n is equals to of 1, may I know the first data would be 5 plus 1, that would be 6. N would be kept as a 1 divided by of root 4. You can just write like this. Plus the next term would be the second term. The second term is nothing but the 5 plus 2, that would be 7. 7 divided by of 2. 2 gets added with 3, that would become 5, and that would keep move on. The nth term would be n plus 5, n root over of n plus 3, and as you can see very well, the discrete sum was taken from the first term till the infinite term. That means it will keep going. Yes. So probably you guys are sort of connecting the things what the sir is saying and how the problem may get framed. So anyways, come back to this. Agreed? So till this point I feel each one of us would be much comfortable how the different kinds of the infinite series would look like. Either it would be straight away given in terms of the addition of the numbers, or either it would be given in terms of discrete sum of the nth term. May I know what it is? It's the nth term. It is nth term. A suffix n. Yes. So this is all about the definition of the series. Anyways, secondly, I need to go into the classification of infinite series. I need to go into the classification of the infinite series. Yes. The classification has been clearly given. I would have only the two categories of classification. Only two categories of the classification. The first category is going to be positive term series. And the second category is going to be alternating series. You will not have any other series apart from these two series. Positive term series and alternating series. May I know what does it mean by the positive term series? If you have the addition of all positive numbers, like the first number is positive, second, third, fourth, fifth, till the infinite term, all of the number including nth term and till the infinite term, if all of the numbers are positive, you can have the another way. If all of the numbers are negative, many of us would have a confusion, sir. Why don't we have the negative term series? See, impact of positive and negative term series is very same. See, the minus sign can be brought common together. Again, you will be having a series which every and each number is positive. That is why even if all of the numbers are negative, still I account that series under the positive term series. Yes, positive term series. And once we'll be going into the concept of convergence, divergence and oscillatory, you'll get to know why this two classification only is the classification of the infinite term series. Till this point each and everything is clear. Even you can have few glitches, like starting 3 terms is negative, but rest of the all terms are positive. Still it would come under the positive term series. Why? Now the people will ask why. See here, if 3 terms have been negative Exclusively you can add them together and you'll know its finite value. But if you talk about the remaining number, if all of them are positive, definitely it should come under the positive term series. Agreed what I am saying? See. You got to know about it that from here onwards each and every data are positive and you had only and only few finite negative terms which you can add them together, and whatever the result comes out from here, you can subtract the result from this number, and that is why again it comes under the negative term series. Negative term series. Agreed what I am saying? I will give you few number of examples so people will understand in the better way. Agreed? Or even you can have few number of positive terms and then goes all of them till infinite term negative number. So if you want, you can write, obviously sir, we wanted to write, so all positive, all negative, few negative. That means only discrete few number of negative terms you have, and apart from those finite number of negative terms, remaining all terms are positive. All terms are positive. Similarly, only few positive terms. Yes, till this point each and everything must be clear to all of us. Even by giving few number of examples, I will let you know which are the examples would come under the positive term series and which are the examples would come under the alternating series. Yes. Now the name of the alternating series itself is self-explanatory. May I know? Here once you'll add the series together, you'll get to know the signs are chattering or whether the signs are getting alternating. That means if the first is positive, the second has to be negative, positive, negative, positive, negative, positive, negative. Yes. It would be an example of alternating series. Or the first is negative, second is positive. Again, it would be an example of alternating series. Till this point, each and everything must be clear to all of us. And by just giving few number of examples, I am just cross-checking whether you guys could understand which problem would come under the positive term series and which problem would come under the alternating series. Yes. So let me take few number of brief examples. Just a minute. So let me take brief examples. Let me take the first problem, and you guys had to reply over the chat box, and whenever you are replying, first write 1 and then reply whether it's a positive term series or whether it's a oscillatory or what alternating series. The first problem goes like this: n starts from 1 and goes till infinity. Tell me, would it be, or the series which would be coming into the picture, which would be an infinite series, would it be a positive term series or would it be a alternating series? Would it be a positive term series or would it be alternating series? That goes your first question. Here comes your second question. N is equals to of 1 to infinity minus 1 to the power of n divided by of 2n plus 1. This goes your second infinite series. Then third. You can have like n minus of 4 divided by of n. N minus of 4 divided by n square you can write. N minus of 4 divided by n square you can write. Fourth. N is equals to of 1 to infinity, and here the number is minus 1 divided by of root over n. I want the input from each one of you. The first one is simply you can write n. So tell me, among the question number 1, 2, 3 and 4, obviously they all are the infinite series. Why? Because their sequences are getting added using the discrete sum, and how many number of terms are getting involved? Infinite number of terms are getting involved. Yes. Anyways, the first one is gonna be simply 1 getting added with 2 getting added with 3, and you can see very well the nth term would be n, and you will go till the infinite term. If all of the data are positive, by default nobody can restrict me to say it's a positive term series. term series. Nobody can restrict to say it's a positive term series. And similarly, now let me go into the second one. What is happening over here? The minus 1 to the power of n would make it alternating. Like in case n is 1, the number is gonna be minus 1 divided by if n has been kept as 1, denominator is gonna be 3. Yes. If I take the second case where the n is 2, so what will happen? Minus 1 to the power of 2 would it make it plus 1, and here it becomes 2 to the power 2 into 2, that's a 4 plus 1, that's simply equals to 5. Agreed what I am saying? And similarly again is gonna be minus, and here it becomes 2 3 ja 6 plus 1, and that's nothing but 7. So may I know nth term? Nth term is already known to me. It's minus 1 to the power of n, 2n plus of 1, and here you will be going till the infinite term. And you can see very well, once we'll discuss or once we'll focus on each and individual term, the terms are alternating. So obviously it's gonna be alternating term series. Yes, everybody will agree on that. Nobody would have any ambiguity on it. Now, exceptionally I have taken this value. If we'll keep n is equals to of 1, here it would become minus 3 divided by of 1 plus, and if we'll keep n is equals to of 2, what will happen? 2 minus of 4, just a minute, 2 minus of 4 would make it minus, that would be minus, yes, it would become 2 divided by of 4, yes sir, obviously yes. See what is happening over here, till n goes 4, all of the datas would be negative. But once you reach to n is equals to a 5, may I know what's the result over here? It's a 5 minus 4, that's a 1 divided by of 25. And from here onwards, all of the datas till the infinite term, they all are positive. Yes. So the 3 is also known that yes, such chunk of the datas are positive, but still there were few fringes element which were negative. What does it mean of it? The result is quite self-explanatory. It's again a positive term series. Nobody should have any doubt in it. Positive term series. Agreed what I am saying? Similarly, let's go ahead with the fourth question. Here the first data would be minus, the second data would be minus, and it would keep go on. Just a minute. 1 divided by of root 2 minus of 1 divided by of root 3. The nth data is gonna be 1 divided by of root n with a minus sign, and you will be having the infinite number of term. So again it would come under the positive term series. So let me brief about the each and individual series. Yes, the first is going to be positive term series, the second is going to be alternating series, the third is going to be positive term series, and similarly even the fourth is also going to be positive term series. So let me go back to my problem again. So if we talk about the first question, second question, third question, may I know the first question would come under what? The first question would come under the positive term series. There is no doubt in it. Positive term series. Why? Because all of the datas are positive. It's a positive term series. Nobody should have any doubt, at least on this question. If I go ahead with the second question, may I know whether it's a positive term series or the negative term series? Obviously, again, it's gonna be positive term series. Nobody should have any doubt on it. Agreed till this point. Let me go ahead with the third question. And if I come to this question, see, if you start keeping n is equals to 1, first data is positive, second data is positive, third data is positive, fourth data is positive, and may I know precisely what it is? It is nothing but the nth data. May I know, would it be a positive term series? Would it be an alternating series? There is no doubt about it. It's gonna be positive term series. Agreed till this point? Positive term series. So let me show you more number of examples. May I know, would it be a positive term series? Obviously sir. Nobody can say it's a alternating series, sir. It's a positive term series. So probably you would have a fair idea. you would have a fair idea, sir, what the classification of the series was wanted to communicate, sir. If all are positive, positive, partially negative, positive, all are negative, positive, partially positive, positive. Could you agree what I'm saying? Could you agree on what I'm saying? And if there is an alternation, alternation could be plus minus, plus minus, plus minus, or it could be even minus plus, minus plus, minus plus. In both of the cases, it would be alternating series. It would be alternating series. Yes, so let me go ahead with the next page. Let me go ahead with the next page, and here what I am going to discuss, as I have said, once you will add them together, all of the infinite number of terms which makes it infinite series, if the result reaches to a finite fixed value, then that series or the infinite series is called Converges series. What it's called? Converges series. If we add them together and it reaches to plus infinity minus infinity, then I would say diverges. And similarly, end of the day, if we add them together and end of the day neither I am reaching to a fixed value, either it could be a finite or infinite, then it will be a just oscillatory in nature. So what I am going to do now, just I am going to take an specification. Now I am just going to take a specification here. My infinite series will be further bifurcated on the base of it is sequence present in gate. Obviously, that is what I am saying, Diptansu. What Dipansu, probably you are not attending from the beginning of this video. You will see around 4 to 5 number of problem have come on gate examination. So definitely it is there in your syllabus. Yes. No partial alternating series. Yes. PS, if you are saying partial alternating series, so give me the A of n for that. If you want, you can just draw that. If you want the partial like plus plus, minus minus, plus plus, minus minus, if you have any A of n for that, just comment over the chat box. You will not have any A of n for that. Agreed what I am saying? Now what I am saying, the infinite series can be further bifurcated, further classified, further splitted in terms of its solution. In terms of its solution. The first kind is gonna be converges. Anyways, we'll try to understand graphically how a infinite series would converge. We'll try to understand about it. Yes, secondly, we would be discussing about a series which diverges. And thirdly, we would be discussing about the series which oscillates. Yes, the 3 different scenarios we are going to discuss, and we'll try to understand the given infinite series would fall under which solution, convergent solution, divergent solution, or oscillatory solution. And keep in mind, in gate examination it would be a problem from MCQ, and probably they would design the 4 number of options, and one options would be a vague or false option. Why? Because you can have only 3 number of solutions. You can have only 3 number of solutions. If you want, I can show you. See, converges, diverges, oscillate. Unnecessarily I need to write unstable. Is unstable? No. So the answer could have been A, B, or D. Similarly, if I go down, go up, and here also I have asked you to give the answer. Obviously, the 3 could be the possible answer. The unstable is not an answer at all. Unstable is not an answer at all. And even which has been asked in your problem, which have come in gate civil engineering, and as I have mentioned earlier, electrical, electronics, as well as instrumentation. Here also the same concept goes on. Out of 4 number of options, if somebody is writing the correct answer is D, so he would be the last joker in mathematics, because as far as this problem is concerned, unstable is not the appropriate option at all. So as far as this complete topic is concerned, you can have the 3 categories of solution. The 4th category, they would write anything. Unstable, cannot be determined. Anyways, you can have only 3 many options. Agreed what I am saying? So till this point, each and everything must be clear to all of us. Agreed? Now let me go back. Now tell me when the series would said to be convergent. See. it would be said to be convergent if all of the terms of Sn, or this can also be written as if all of the infinite term in Sn and once the addition was taken place and the value was fixed and finite. If we added them together, the value or the result was fixed and finite. Like the answer could have been +2, the answer could have been -3, could have been +4, could have been -4. It should not be plus infinity, no sir. It should not be minus infinity, obviously sir, no sir. And it should not be fluctuating. I'll show you few number of examples and few number of graphical outcomes. You'll get to know about it in the better way. Agreed what I'm saying? And diverges, what does that mean of it? That means we are keep adding the series or the sequences, and end of the day we landed at plus infinity or we landed at minus infinity. So here it goes like, I will show you guys graphically, you need not to worry about it. If you are watching my video, the each and everything in mathematics would get cleared on the concept of graphs. Is that part clear? So here is gonna be limit n tends to infinity. It goes limit n tends to infinity 1 to n a of n. Either it goes to plus infinity, it diverges, either it comes to the minus infinity, again it diverges. Yes. So what is the requirement to a series to be divergent? Plus infinity or minus infinity. It must get to the fixed value of plus infinity and minus infinity. Yes. Fixed value also will include 0. Yes. Now we come to the oscillatory series. Try to understand. I'll give you a few number of examples. You guys would agree in that case. Otherwise, you will be in big trouble or big confusion. If all of the infinite term got added together, even mathematically you can write limit n tends to infinity, discrete sum of a n, where the n starts from 1 and goes till n, where the n tends to infinity. And if the result is ambiguous, that means you yourself is not able to find. If the result is ambiguous, that means you yourself is not able to find how much would be the worth, then it becomes oscillatory. Yes, till this point each and everything is valid. Okay, let me take few number of examples. And these examples are going to give you a very good insight of the concept of this 3. Anyways, let me take the first case. 1 upon n square, where the n goes from 1 to infinity. If you guys are not aware, at least try to understand this problem on the basis of graphs. See, let's take here, we have n is equals to 1, n is equals to 2, n is equals to of 3, and it goes on till the infinite term. So may I know what would be the first term? 1 divided by of 1 to the power of 1, that would be 1. And as you will reach to n is equals to 2, it would become 1 divided by a 4, that would become 1/4. And similarly, once you will go to the n is equals to 3, it would become 1 upon 9. May I know now if you are adding them together, would it converge to a finite value? Would it diverge or would it oscillate? Obviously, sir, the first, second, or you can say the initial data were powerful data, large data, but as we go towards right hand side, the worth of the data are so small, even we add them with the earlier data, still you would be getting a finite value, positive finite value, you can see very well. So may I know which type of infinite series it would be? Definitely n belongs from 1 upon n square would be a convergent series, because the result would be obviously finite. Result would be all obviously finite. Now if I take another result or another situation, the situation is like n is equals to 1 goes till infinity, and let's take its nth term is n square. Let's take its nth term is n square. So graphically, if you want, definitely I can again take the reference of graph. Let me take the again reference of graph. So what would be the offering over here? So here the first data would be 1, the second data would be 4, the third data would be 9, and similarly the fourth data would be 16. Yes, here it would be 1, here it would be 4, here it would be 9, here it would be 16. Here it would be 16. Agreed what I am saying? So what does it mean of it? That means once all of the datas are getting added, you can see very well, it is keep increasing data. So till infinite term, if you add them together, you would be reaching to the result of plus infinity. So which type of data it is? Definitely it's gonna be a divergent data. It's gonna be a divergent data. Is that part clear? So you can say very well, it is nothing but a divergent data. It is nothing but a divergent data. Yes, it is nothing but a divergent data. Till this point, probably each one of us would have a clear-cut idea. How did we notice about it? Yes, let me go ahead with the next page. Next page, just a minute. I am adding an extra page. And let's take the page sort of this. Let's take the page sort of this, minus 1 to the power of n, where the n goes from 1 until infinity. May I know what would be the first data, what would be the second data, what would be the third, fourth and fifth data? The first data would be plus 1, second data would be minus 1, third data would be plus 1, fourth data would be minus 1, fifth data would be plus 1, sorry, minus 1, and goes on. The first data, probably it would be reversed. No? Let me take this as reverse. The first data would be minus 1. It is n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5, n is equals to 6, n is equals to 7. We'll see that. What Rabbi Das has to say, sir, but sir, if we not putting upper limit as value rather infinity, then also it converts. I could not understand, but anyway, still end of the day, you will be able to understand the each and every concept. Now tell me, what would be the result of this? See, if you take the first data, the result is minus 1. If you take the second data, result is 0. If you take the third data, result is minus 1. If you take the fourth data, result is 0. And similarly, if you take the fifth data, the result is minus 1. If you take the sixth data, result is what? 0. Put together, I do not know if we add them together till the infinite term. Exactly, the infinity is not getting decided. It's not at all decided. It's a very large data, but once you add them together, all of the terms over the sequence, the result would be either minus 1 or 0. But you cannot decide whether would it be minus 1 or would it be a 0. So obviously, this type of infinite series would come under the oscillating series. Yes, would come under the oscillatory series. So probably you guys would have a fair idea. What the sir was saying. Now definitely with the help of this, I am going to go ahead with the numerical understanding. With the help of this, we are going ahead with the numerical understanding. Now, one more important thing. See, as I have classified infinite term series in the two parts. First, positive term series. And the second is gonna be alternating series. Obviously, sir, you did that. Now the positive term series, within the positive term series, out of 3 different kinds of solutions, only 2 solutions are possible. Either it can converge to a certain fixed value, either it can diverge. Now the people would ask, sir, why oscillation is not possible? See here, if it is positive term series, all of the terms would be towards the upside. If all of the terms may get added to infinity, or if all of the terms are keep suppressed, what will happen? End of the day, if you add all of the terms together, they might get divergent, or they might get reaching to a perfect finite value and they could get convergent. But never you will come across a situation where you are not able to figure out the result is whether a finite value to a two distinct finite value. Yes, agreed what I am saying? So the positive term series would have only two possibilities, either it would converge, either it would diverge. There would not be any other possibility. Similarly, alternating series would have only two possibility, either it will converge, or either it would oscillate. Now the people will ask, sir, why don't it diverge? See. If it is keep expanding, larger, more larger, more larger, and once you'll add them together, the larger value would make it positive infinity. Again, larger value which is coming towards the downside would make it negative infinity. End of the day, you did not conclude whether it is divergent or not. You will just say, sir, I am not able to conclude what is the fixed value out of the given series, and hence it would become oscillatory series. If you guys are not able to understand in that great detail, anyways in crash course, and my intention is not to go into the great detail, but my intention that much amount of information I should communicate such that you would be able to smash all sort of problem like Australia have done with the India in today's match. Yes. Till this point each and everything is clear. Till this point each and everything must be clear, and this is very, very important as far as cracking the problem is concerned. Is that part clear? Is that part clear what I am trying to say? If you have a positive term series, you need not to think about the oscillatory. And similarly, if you have an alternating series, you need not to think about the divergence. Agreed? Yes. So let me ask one more thing. Out of 4 options, 1 option could not be the correct answer, that is unstable, and even the oscillation would not be true. Why so? Because it's a positive term series, and in positive term series there would be only 2 options which would be left out, and that is nothing but the convergent or divergent. Is that part clear to all of us? If I go down, let me go down, and if I go down again, being a positive term series, unstable is not an option at all. Similarly, oscillation is not an option at all. You would be left out with the convergence as well as divergence. Keep in mind. And if I take the third case, again it's a positive term series. Unstable is not a possible case at all. As far as the positive term series is concerned, even oscillation cannot occur. Convergence, no, you should not say any answer about it, because we had to think a lot, we had to learn a lot, then only we'll reach to a certain final conclusion that which particular infinite term series is convergent or which particular infinite term series is divergent. Agreed till this point? So let me go ahead with the working board. Yes. So now I'm going to give you a chart, a flow chart, as we do in computer algorithm. Once you go through that chart, you'll have a fair idea how to crack any sort of problem which have come related to the infinite series, and we are going to deal with its convergency. So what I will do, see, we are going to draw a flow chart. At very beginning what he'll do, you would be having an infinite term series. You will get the value of its infinite term. Yes. If it is non-zero, try to understand. What was the infinite term series? The infinite term series was the sum of the infinite term sequence. What you will do, you will go to the last term and you will ask whether you are 0 or non-zero. Try to understand. If the last term is non-zero, what does it mean of it? That means you are keep adding each and individual data. Even the lastmost term is also non-zero. That means their addition would be either plus infinity or the minus infinity. Yes. And if we got to know, yes sir, yes, what does it mean of it? That means the last term of the sequence is not equals to 0, that means your series would be divergent. Series would be divergent. Agreed what I am saying? Till this point, each and everything must be clear to all of us. See what I am saying. Once you are dealing with the infinite term series, you get to know, you will be knowing about its nth term. Now, limit n tends to infinity, a of n indicates it is just asking what is your infinite term or what is your last term. If the last term itself is not 0, what does it mean of it? That means the data might be reducing, data might be increasing, but the last term is not 0. That means the addition of all of the data would be either plus infinity or minus infinity. Together I can say, yes, that given infinite series diverges. Now, if the situation is no, if the situation is no, that means the limit n tends to infinity, a of n was 0. So what you will do? Nobody should say, hey, sir, it is convergent. No, you had to go further. And you would be using integration test. And you will check whether the problem or the given problem can be smashed using the integration test or not. Yes, if it is applicable, that means in the given problem, if the concept of integration test, if it is applicable, the result would it be coming in a form of divergent or convergent. Yes, and keep in mind this flow chart is valid only for positive term series. Yes, till this point each and everything is clear to all of us. Let me go down. The few of the problems, you will say most of the problems would not be able to address using the integration test. You will go ahead with the next kind of test, and the next kind of test would be comparison test. Would be the comparison test. Agreed what I am saying? Let's take, we'll see whether the comparison test is applicable on that problem or not, because many of the times it has been seen even the comparison test is also not getting any fruitful outcome for the given problem. Once I'll have 7 to 8 number of problems, end of the day you guys are just would be bang on whether which test has to be conducted. You need not to worry about it. Applicable, if it is applicable, you will deduce that the type of infinite series it is, whether it's a divergent or whether it's a convergent. If this test also is not applicable, so you will go ahead with the next test, and that is nothing but the last test. It's a comparison test. Comparison is already been over. Ratio test. And if the ratio test is applicable, you would be deducing the type of infinite series it is. It is divergent or convergent. And if the ratio test is not applicable, you cannot do with that problem anything, because still 5 to 6 more number of tests are there which can be conducted. But as far as the gate is concerned, you will not get, I am sure about it, you will not get any test which is apart from this two. And worst of the worst case, you may get the problem related to the ratio test. So I wanted to know one thing. Till this point, have you written each and everything? So it starts with the positive term series. That means the test or the flow chart of the test which I have wrote over the digital board is only applicable on the positive term series. And by taking few number of examples, I will let you know how to process slowly, and you'll get the answer out the end. Tell me. Sir, will you provide this video publicly? Yes, I have provided, no. It's not gonna be private in future. It would be there on YouTube. Till this point, have you written each and everything? Especially this flow chart is very important. So everybody should write this flow chart in their copy. Then only you are going to get the good marks, at least from this particular topic, and probably one question is supposed to come. If you have written, each one of you, you just write yes, then I'll get to know that everything is fine. Just a minute. Yes, just write yes over the chat box. Thank you, sir. Now I can join Sujay sir lecture. You can go ahead. Yes. Now, no. Let me take the first question. Go ahead. The students who are interested in joining Sujay sir class, definitely you can go ahead, because the classes of the Sujay sir would get private once his lecture is getting over. So you can go ahead with that lecture, and you can come back in future and you can read this topic thoroughly. And keep in mind, it's a very important topic. Yes, so let me take a problem. Tell me which type of infinite series it is, whether it is convergent, whether it is divergent. I would ask from each one of you whether it is convergent, whether it is divergent. N plus 1 divided by n plus 2. Even in future, this could have been given like this, and probably that question would be a tougher form of the same problem, like n is 1, so it would become 2 divided by of 3 plus of 3 divided by of 4 plus of 4 divided by of 5 dash dash dash. The nth term would be n plus 1 divided by of n plus 2, and similarly you will have the infinite number of term. Tell me, would it be a convergent series or would it be a divergent series? Convergent. One data have come. See. You had to go back with my flow chart. Otherwise, definitely you are going to do mistake. First, you will try to get what is its nth term, and thereafter you will feed n tends to infinity of that nth term. And if the value is non-zero, by default, it diverges. So let me go ahead. So the first test I would apply over here, and that is nothing but limit n tends to infinity a of n. It's gonna be limit n tends to infinity. From here you cannot do anything. Even the problem may come in form of digits, so you had to find its nth term. And now limit n tends to infinity, n plus 1 divided by of n plus 2. So many times the limit has been studied. May I know how do we apply this? It's simply going to be limit n tends to infinity. N has been taken common out. So here it becomes 1 plus of 1 by n, 1 plus 2 by n, and here it's simply 1. It is not important that the value was 1. The important point is it is not equals to 0. That means the last of the last data was also a finite data which was not 0. That means once you will add all of the positive term together, the result would be a divergent series. Is it part clear to all of us? If it is clear, just give a thumbs up, because we are going to take few more design number of problems. Yes. Let me take another problem. Let me go into the next slide. Yes. Sorry, sir. I would be, divergent. Obviously. Let me take another problem. You can take like this. Root over of n plus 1 do one thing, you can take n square over here. Just a minute. Let me do little bit khurapati. Yes, here goes n, here goes root over of n plus maybe 3, where the n starts from 1, goes till infinity. This probably might be looking so simple once we have the problem in terms of the discrete sum of the nth term. But once we deal with the numeric problem, we used to have difficulties a bit. Like the first term would be 1 divided by of root 4. Second term would be 1 becomes 2 now divided by of root 5 plus of 3 divided by of. root 6 and it keep goes on, and the nth term is gonna be n divided by of root over of n plus 3, and it would keep going. It would keep going. So tell me what's gonna be the answer for this? What's gonna be the answer for this? Again the same concept. We would focus over the infinite term. Is it 0? If it is 0, it's a big question mark. If it is non-zero, you keep adding the data. The last data itself is not 0. That means you are keep adding the data. The last data is also not 0. The addition would be either plus infinity, and if all of the signs are negative, it would be minus infinity. End of the day, you can conclude one thing: output or the addition is divergent, goes to plus infinity or minus infinity. So what you will do, you will come across limit n tends to infinity of n here. Just a minute. There is a problem. Do one thing. There is a problem, dear. There is a problem. Do one thing. Keep it n square. Yes. A bit change you will be experiencing. Deliberately I am keeping it this. Otherwise in future, in few tough questions you may get trapped. Yes. So here it becomes 4, and here it becomes 2 to the power of 2. That's a 4. And here it goes 7, and similarly it becomes 3 to the power of 2, that's a 9 plus 3, that's a 12, and here it would keep going. Yes, and again I would be using the same. If n square has been brought out, it would be n outside, and here it would become 1 plus 3 divided by n square. N and n goes out. The result is how much? 1, and which is not equal to 0. Again it would be divergent. Agreed? Now let me do one thing. I have come across a special case, and this is the case where you would not be able to conclude anything from limit n tends to infinity of a of n, and that is why we need to go ahead with the next test. Let's take the problem is sort of 1 divided by of n, where the n goes from 1 till infinity. You can have another problem like discrete sum of 1 upon n square, where the n goes from 1 to infinity. Tell me what would be the responses for the question number 4, and here comes your question number 5. What would be your responses for the question number 4 as well as question number 5? I am waiting for next 10 to 15 seconds to get the response for this particular question. Yes. Integration of 1 upon n. May I know what would be the discrete sum of 1 upon n? You have come across this situation where it would become 1 upon 1 plus 1 upon 2 plus 1 upon 3. The nth term would be 1 upon n, and it would be an infinite term series. Even you can write this also. 1 upon 1 divided by of 1 upon 2 square, which would be 1 upon 4, 1 upon 9, and it would keep going. Sir, it is n in spite of n square. Please, I will discuss each and everything. Surjit, I think you have not been following me. I know which type of problem can get framed in gate examination and which type of doubts you guys would have that. You need not to worry about it. You just go through the complete video. End of the day, you would be bang on the concept of convergency and divergency. No. See. If I take the question number 4, limit n tends to infinity of a of n is, which is gonna be 1 upon n, which becomes 0. Yes. Question number 5, limit n tends to infinity a of n, which is 1 upon n square, again becomes 0. If you guys would be able to recall, what was my conclusion? See, if an is not equal to 0, by default divergent, but if an is not equal to 0, condition is false. That means if you have come to the situation where the limit n tends to infinity a of n is 0, you cannot conclude that it is convergent. Then what you have to do, the further test has to be conducted. Either the integration test, either the comparison test, either the ratio test. Yes, obviously the next test has to be conducted. Till this point, probably the things must be clear to all of us. So let me focus over the integration test. Let me focus over the integration test. First, we'll try to understand the integration test is applied on which pattern of the infinite series or which pattern of the problem. So that should come in your mind. That should come in your mind. See, the structure of the problem should be 1 divided by of n to the power of p. N to the power of p, obviously, being an infinite series, the n would go from 1 to infinity. N would go to 1 to infinity, 1 to infinity. So this sort of problem would be dealt easily using the integral test, Just try to understand how the integration would get connected with this problem. See, it was a discrete signal. You can see, no, at n is equals to 1 it would be defined, at 2 it would be defined, at 3 it would be defined. But how a discrete sum is getting connected to a integration, where the integration used to be a continuous tool, where the area under the curve has to be calculated within a continuous time frame. So we'll try to understand how the things are getting connected. Just try to understand in this way. See, we have got a plane. Let's take its n is equals to 1, n is equals to 2, 3, 4, n is equals to 4. Agreed? Till this point each and everything is clear? Now tell me, depending on the different values of p, you will be having a different patterns. I'm just drawing a rough draw. Like, it could have been 1 divided by of 1 to the power of p, that would be 1 anyhow. It would be 1 divided by of 2 to the power of p, 1 divided by of 3 to the power of p, 1 divided by of 4 to the power of p. Yes. The p, may I know what would be the p over here? P could be anything in between greater than 0, where the p could be anything greater than 0. Obviously, it can't be 0 and it can't be negative. If it is negative, it would become alternating series, which I don't want. Now, what I am going to do over here, see. If addition of this all component reaches to a finite value, by default, this infinite series would converge. So I can take the help of convergence of the integration. May I know what I am going to do? I am going to draw a continuous curve with the help of this discrete outcome. If the sum of all of the sequences, reaches to a finite value, that means my series is convergent. In that case, area under the curve of what? Integration. Instead the x, I have taken x to the power of p. Integration from x is equals to of 1 to infinity, should be finite. Yes. So what I am going to do, the discrete sum or the infinite term series is getting connected with the integration. So whenever its output is finite, or whenever this integration converges, by default, my infinite series would converge. May I know, have you seen this integration earlier or not? Yes. The student who have been following me till the first video, till this video, definitely they know this integration is already been assessed. Where? When I was discussing about the improper definite integral. Why improper? Because the limit either starts from minus infinity, goes to plus infinity, then by default it becomes a improper. Anyways, I am not going into the derivation part of it. Already it is there in my playlist. You can go ahead with the derivation. 1 upon x to the power of p dx, when it would be divergent, if the integration has been taken place from 1 to infinity. We have seen, in case of p is equals to of 1, it is divergent. If you want, you can see my previous videos. The student who have been following me, they know from where it has come. Similarly, if P is in between 0 to 1, still it is divergent. Still it is divergent. And if the value of P is greater than 1, it would be convergent, and it would converge to a certain value, 1 upon probably 1 minus P, something we have calculated. Yes. The student who are able to recall, just say yes, because many of the students or few of the students, they have been following me since the starting video. They will at least recall where it has been taught. So what does it mean of it? That means if this integration converges, by default this infinite series would converge. So may I know what is the requirement? The requirement is to keep the value of P is greater than 1. The requirement is keep the value of P greater than 1. The requirement of P is greater than 1. Yes. That means whenever the P is greater than 1, not even 1, in case of 1 the result diverges, not even lesser than 1. If P is greater than 1, by default this integration diverges. This integration converges. Yes sir, from linear algebra. Yes. So let me go ahead. So let me write few of the problems. Yes. Whether it's a convergent series or divergent series. So you will start with the first one, limit n tends to infinity a of n, which becomes 0. So definitely you had to come to the integration test. Similarly, if I take the next problem, 1 upon maybe 1 the infinite term, the nth term would be 1 upon root n, and you will be having the infinite term. So tell me what would be the result of the first question, what would be the result of the second question, what would be the result of third question. Sumit Gupta, hide here. Anyways, here, tell me, would it be a divergent or would it be a convergent? You can easily connect with the last slide. See, it would be convergent only and only if the value of P is greater than 1. Sorry, it is not 0. It's greater than 1. Sorry. It is greater than 1. Yes, it's a greater than 1. Tell me, what's the worth of P over here? The value of P is simply equals to of 1. It would be a divergent series. Yes. Similarly, you can write this problem as the discrete sum of 1 divided by of n to the power half or root over of n, where the n goes from 1 to infinity. Again focus on n to the power which is half, obviously lesser than 1, and hence again it would be divergent. Last come this. May I know what it would be? It can be written in terms of discrete sum of the nth term. And what's the nth term? Here deliberately I did not show the nth term, but once you will focus on each and individual term, you will get to know it's a 1 upon 1, it's a 1 upon 2 square, it's a 1 upon 3 square. In first place it was 1 square, in second place it was 2 square, in third place it was 3 square, in nth place it would be 1 upon n square. And here it goes. Here 2 is greater than 1 and it converges, and it converges. Yes, convergent. Yes, so let me go back. Tell me what would be the answer for the first question. So I want the answer from each one of you. What's gonna be the answer for the first question? This problem have come in civil engineering, electrical, electronics and instrumentation in different years. Electrical, electronics and instrumentation. Instrumentation. Tell me what's gonna be the best most answer. Being a positive term series, you cannot have answer as oscillatory. Unstable is not a answer at all. Now you have been stuck in between divergence and convergence. So what would be the answer? The answer is gonna be B. Why? Once you'll write in terms of discrete sum of its nth term, you'll get to know it's simply 1 upon n, or where the power of n is 1. The n goes from 1 to infinity. 1 to infinity. So obviously the value of P is precisely equals to of 1. Keep in mind for which the infinite series diverges. For which the infinite series diverges. Yes. Go ahead with the next question. Go ahead with the next question. This is what my next question is. This is what my next question is. Deliberately I have designed this problem. Tell me what would be the answer for this. Again, it's a positive term series. How did we know? Because all of the terms are positive. Anyways, oscillation is not an option at all once we deal with the positive term series. Yes, even it could have been a divergence or convergence, but unstable is also not a possible answer. So tell me what's gonna be the answer over here. Again it diverges. Again it diverges. May I know what is the next one? No, this problem we cannot solve from here. Anyways, we'll come down. So till this point, each one of would have a clear-cut idea. Each one of us would have the clear idea. Now let me go ahead with the comparison test. Let's see when the comparison test is so important, or when the comparison test becomes so fruitful. See, comparison test. Now, so far, you could have seen one thing. Integration test can be applied to a very limited form of a of n when you have a problem of 1 divided by n to the power of p. Apart from this, if you have any sort of nth term, you would not be able to conclude whether would it be a divergent or would it be a convergent. So you should have a clear-cut idea which type of test has to be applied. The last test, which was an integration test, can be applied only with the problems like 1 divided by of n to the power of p, where the p could be anything in between 0 to 1, including 1 and greater than 1. If it is greater than 1, it would be convergent, and if it is 1 or in between 0 to 1, it would diverge. Yes. Comparison test. Try to understand in this way. If you have infinite series, instead the a of n, deliberately I have written u of n. N goes from 1 to infinity. If you guys are having any problem, you can write u of n is nth term. It's nth term. U of n is nth term. Now, try to understand. If limit n tends to infinity, u of vn is a finite value, or I can say we have v of n for u of n such that, so now you have got another kind of infinite term series, which is discrete sum where the n is ranging from 1 to infinity of u of n. Yes. Now we have got another nth term v of n such that the limit n tends to infinity of u n divided by of v n is finite. Then series of un and series of vn converges or diverges together. I know many of us might be scratching their brain what has been written over there, but anyways, if you are a teacher, if you are taking my classes, end of the day using few number of examples, you will get to know about each and everything. Yes. Anyways, we start from here. We have, okay, yes, yes. Again you can write the important point. Outcome of integration test is used. Integration test is used. Outcome of the integration test is used. Yes, 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 yes. Yes, go ahead with few number of problems, probably 2 or 3 number of problems I am going to design over here itself. Yes, let me take this problem. I am going to take a problem. I have got a infinite term series like you can say like n divided by of n plus 1, n plus 2, n plus 3, n plus 3. Yes, yes, this is what my question is. Tell me whether it's a convergent or whether it's a divergent. So we'll start with the first test. Limit n tends to infinity a of n. Once you'll take limit n tends to infinity a of n, you'll get to know the degree of denominator is higher than the degree of numerator, the value will become 0. If the limit n tends to infinity a of n becomes 0, that means you cannot say whether it's a convergent or divergent. You had to go with the next test. May I know what used to be the next test? The next test used to be the integration test. See, but the integration test deals with a very minimal criteria of the problem, where the problem has to be in the form of 1 divided by n to the power of p, which is not there. Which is not there. Yes, which is not there. Then how will you solve this problem? How will you solve this problem? See. First, I would get the nth term. May I know its nth term is n divided by of n plus 1, n plus 2, n plus 3. Agreed? Agreed. Now for the un, I would like to extract a vn such that where the limit n tends to infinity u of n by of v of n has to be a finite value. So how do we design vn? That has to be clarity in each and individual's brain. What I will do, I will get the highest power of n at numerator, and similarly I would get the highest power of n from denominator. So may I know what is the highest power from the numerator? It's the n, and what's the highest power from the denominator? N and n. It becomes n cube. So n divided by of n cube is simply equals to of 1 upon n square. 1 upon n square. Yes. 1 upon n square. So what you will do? You will feed the value of v in. V in is equals to of 1 upon n square. Yes. 1 upon n square. Now the people will ask, sir, why Vn has been kept as 1 upon n square? If you keep Vn as 1 upon n square, there is no doubt in it. In future, if you will calculate limit n tends to infinity, the ratio of un by Vn would be always a constant. Why? Because the deformations, or you can say non-uniformity between the degrees of numerator and denominator has been brought it out, and now it is getting divided at denominator. That means now the numerator and denominator would become uniform. Yes. So here it becomes u, n, it's nothing but n divided by of n plus 1, n plus 2, n plus 3 divided by of 1 upon n square. And even the n has been brought it out. If the n would be brought it out, the n would come from here, and similarly n cube would come from here. It would become n divided by n cube, which would be 1 upon n square. 1 upon n square and 1 upon n square goes out. So may I know what would be left out? It would be simply limit n tends to infinity. And the component which would be left out is simply going to be 1 plus 1 divided by n, 1 plus 2 divided by of n, 1 plus 3 divided by of n. And may I know, once you will feed n tends to infinity, would it be a finite value or not? Obviously it is plus 1, which is a finite value. It should not be 0. Finite value. Yes. Could you understand what I'm saying? Now, what the last conclusion was saying, un and vn, if they have been divided together, limit was brought towards infinity. In that case, if the result is finite value, infinite series of un and infinite series of vn would converge or diverge together. What does that mean of it? That means if the infinite series of u1 is converging, by default vn would converge, and if the infinite series of vn is converging, un would converge. May I know what is vn over here? Vn is equals to 1 upon n square. 1 upon n square. Tell me, whether it is convergent or divergent. Tell me whether it's convergent or divergent. I want the input from each one of you. We have seen, my dear friend, Vn is 1 upon n square, where the value of p is 2. If the p is greater than 1, by default, the infinite series of Vn is convergent. And now, by default, un would also converge. Un would also converge. Yes. Yes. Till this point, each and everything is clear. Anyways, I know still few of the students might be having a big dilemma how to solve related to this problem. Once I'll be taking few number of questions, you'll get to know what's gonna be the answer over here. It's a convergent. It's gonna be convergent. So let me give you around 2 or 3 number of problems over the workboard, and you guys had to conclude whether which type of outcome it would be. Which type of outcome it would be. Let me take the first problem. You can take like second one. Yes, this could be the second problem. Third problem. This could have been like tell me what would be the answers? What would be the answers for the question number 1, 2 as well as 3? And I know, Ambika, bit clear. Okay, there is no problem at all. Now using this 3 number of questions, easily you would be able to understand the each and everything. And anyways, all of the 3 tests requires the comparison test. The comparison means I'll compare the infinite series of un with vn. If vn is converging, un would converge, and if vn is diverging, un would diverge. Vn would diverge. I want the answer for the question number 1 as well as 2 as well as 3. I'm just giving the time of 15 seconds to give or to reply the proper answers for all of these 3 questions. Tell me what's gonna be the best most answer for this given 3 questions. For this given 3 questions. The first is divergent. See, how will we approach the first question? How will we approach the first question? What I will do, I will draw the Vn out of this problem. What would be the Vn? That would be the highest power from the numerator would be brought out. The highest power from the denominator would be brought out. The highest power from the numerator is root over n, and from the denominator it's n. So the Vn is simply gonna be n to the power of 1 by 2. Just a minute. Vn is simply gonna be 1 divided by of n to the power of 1 by 2. 1 by 2. Yes. In future, what you'll do, you need not to worry about it. You had to divide this with 1 divided by n to the power of 1 by 2. You'll feed limit n tends to infinity. End of the day, value would be finite. There is no doubt in it. That is why I have said the highest power and the highest power from the numerator and denominator has to be brought out, and in future I'll divide with that such that the ratio between u and vn would always be constant. Would always be constant. Agreed what I'm saying? So what is happening over here? You can see very well in future if you'll make an infinite series of Vn, which is a discrete sum of n goes from 1 to infinity of 1 divided by of half. May I know what's the value of p over here? What's the value of p over here? P is lesser than 1. That means there is no doubt in it. There is no doubt in it. Vn would diverge, and along with Vn, un should also get diverge. So as far as the first problem is concerned, the best most answer is gonna be divergent. Best most answer is gonna be divergent. Yes, if we talk about the second one, the highest power which would be brought out from the numerator is gonna be n, and from denominator it's gonna be n square. So may I know what you would be selecting as Vn? Vn would be equals to of 1 upon n. That would be value of Vn. That would be value of Vn. Yes. And here you can easily see the P is precisely equals to of 1. And if P is precisely equals to of 1, what does it mean of it? That means the infinite series of Vn is divergent. Agreed what I'm saying? Divergent. And even their ratios was found to be finite, which already been found finite. In that case, the infinite series of un and vn would converge and diverge together. If vn has already been diverged, even un has to get diverged. See. During this complete process, what I am going to do, I am just going to extract the vn out, and by comparing with the outcome from the integration test, I just concluded whether my discrete sum of un, whether it's a convergent or the divergent. Agreed what I am saying? Till this point, each and everything is clear. So if we talk about the first one, it's a divergent because the Vn was divergent. Similarly, what about this? It's a divergent. Why so? Because the Vn was divergent. Vn was divergent. Yes. And similarly, what about this? I want the answer for the question number 3. I want the answer from each one of you. Tell me, what would be the answer for the question number 3? So the best most answer for the question number 3, here the value of P is equals to 2, obviously greater than 1, and hence it would be converging. Agreed? So you can write over your copy, and if you guys could not understand what was the basic behind this complete calculation, you can go through few of the previous pages, and you can go back to videos also. Yes. Till this point, probably each and everything is clear to all of us. Yes. So let me do one thing. Just a minute. The second question was done earlier. Tell me, what would be the answer for the question number 3? What would be the answer for the question number 3? I want the exact answer for the question number 3. N plus 5 divided by of n root over of n plus 3. Deliberately I have designed the problem in such a way you guys may find this problem a bit difficult. Anyways, start from the first one. Limit n tends to infinity, a of n would become 0. You cannot use the first test. The second test, integration, cannot be used as far as the structure of this problem is concerned. You will go ahead, you will come to the comparison test. Tell me, what would be the answer for this? The discrete sum where the n goes from 1 to infinity, n plus 5 divided by of n root over of n plus 3. Tell me what's going to be the answer. I may come to this side. Tell me what's going to be the best most answer. I am giving the time for the 10 seconds and you guys have to reply, and this sort of problems are supposed to come in your gate examination. Yes, tell me. Diverging. Only one answer I have got so far, and in future you can expect the problem may come in this way also, like it may come like 6 divided by of 1 into 4 plus 7 divided by of 2 root 5 then 8 divided by of 3 root 6. They may ask this also, no? Till the infinite term, which type of series it is, whether it's a divergent, whether it's a convergent, whether it's oscillatory, or whether it is unstable. In that case also, you had to draw its nth term. The first term is 6, second is 7, third is 8. By default, at numerator it's gonna be n plus 5. The first term was 1, 2, 3. By default, it becomes n, and here it was sort of n plus 3. Yes, this sort of problem may also come. And dealing with this sort of problem is easier in compare with this. Why? Because until and unless you do not know its nth term, no, you may not be able to crack this problem. You may not be able to crack this problem out. So I would suggest to each one of you, whenever you come across with the loose data, always try to get its nth data and try to remanufacture the problem in this way, where we talk about the discrete sum. Yes. So again, we'll try to get the value of Vn. From numerator, the n can be taken out, and from denominator, n divided by root n can be taken out. So the worth of Vn is concerned. What is the worth of Vn? It's a 1 upon n to the power of half, where the p is in between 0 to 1. That's it. Vn is divergent, and hence the un would also be divergent. So the best most answer is B. Tell me what would be the answer for this. Deliberately I have designed few of the problems such that you guys would have the better practices. See, this type of problem definitely can ask in your GATE examination. Tell me what would be the answer for this. From numerator, 3 would be taken out. From denominator, 5 would be taken out. So the value of Vn is going to be 1 upon n square. The value of p is greater than 1. By default, it would be converges. Agreed what I am saying? It would be converges. So till this point, each and everything must be clear to all of us. May I know what is the a of n? It's the n cube divided by n to the power of 5 plus of 3. Yes. Let me come back to my working board, and the last test which would be discussed in today's class, and that is going to be ratio test. See, when we deal with the ratio test, usually we deal with the ratio test when we had to deal with factorial, when we had to deal with exponent of the powers, when we had to deal with few unknowns like x, y or z in your series expansion. So now this thing should come in your mind when the ratio tests are dominant, or when the problems are supposed to get solved using the ratio test. When the equation possesses the factorial term, equation possesses the exponent term. Similarly, equation possesses at one unknown term. It could be x, y and z, not all together. Anyways, how the test is getting applied, what we do, first we will be having test limit n tends to infinity, a n plus 1 divided by a n. If result is in between 0 to 1, let's take the result which we have found. You can write B, no? You can write B, yes. If B is in between 0 to 1, what does that mean of it? That means the numerator was smaller in compare with the denominator. That means the next data was smaller in compare with the previous data, and hence you can say the data is continuously decreasing, and here the result would be converging. Yes, would be converging. Now if I take another situation, when the B is precisely becomes 1, it's called the failure of the test. You need to go with the further test. Agreed? And now what happens if their ratio is greater than 1? What does that mean of it? The next term, which is n plus 1th term, is greater than the value of nth term. So what will be the outcome? If B is greater than 1, this infinite term series would be divergent. Is that part clear, each and everything? Till this point, each and everything is clear or not? and basically we use with factorial, exponent, and if you have one unknown. Why? Once I'll have few number of problems, you'll get to know why this test becomes so handy dealing with this sort of problem. Agreed? So let me take a problem. I have designed one problem. So using that problem, I am going to discuss a bit. Yes. And you can do one more thing. You can take few number of problems from here also. See. Yes. This problem have come in civil engineering 1999. The problem was framed by IIT Bombay. Yes. Framed by IIT Bombay. And keep in mind, the same sort of problem have been coming in various gate examination, because within 2 hours I cannot take all of the questions, but yes, the problem have come in electrical as well as instrumentation in the same format. And you can see very well the nth term contains factorial, so the ratio test would be a simple test to conduct with. Yes, so what I will do, see, I will take, or I will calculate the value of limit n tends to infinity a of n plus 1 by of a of n. Yes. So what I will do over here? See what it is. It is nothing but a of n. So if I'll feed a of n plus 1, so instead the n plus 1 has to be fed in. So it would become n plus 1 factorial, and thereafter you had to take the square of it. So nobody should get confused in it, because I have seen many of the times the student get confused on this. And denominator, what would be? Would it be a 2n plus 1 or would it be a 2n plus 2? It would be 2n plus 2, my dear friends. Why? Because instead the n, now the n plus 1 has to be fed in. So it becomes 2n plus 2 and the factorial would come outside. Nobody should have any doubt in it. Agreed? Till this point? Very fine. And here goes a of n, which is n factorial, to 1 f factorial, 2 of n factorial. And again I need to feed limit n tends to infinity, and I will try to get the future term, whether it is lesser than the present term or whether it's greater than present term. If future term is greater than the present term, what will happen? The value would be greater than 1 and the result would get divergent. Otherwise, if it is less than 1, result would be convergent. Tell me, what would be the result out of this? If you don't understand, you can just multiply first and thereafter you can address now. Anyways, let me do that only. So here you can write n plus 1 factorial, n plus 1 factorial. Yes, n plus 1 factorial to the power of 2 can be written in this way. Agreed? 2n factorial would come towards the upside. Obviously, sir. And at denominator, what is supposed to come? Yes, n factorial would come somewhere here. And tell me what would be the result. I want the result from each one of you, because it is one of the better design problem. And similarly, here goes your tell me what would be the result out of this calculation. That's fine. Tell me the exact answer. Would it be greater than 1 or would it be lesser than 1 if we take the limit n tends to infinity? Is there any mistake? 2n factorial. Yes, it's a 2n factorial. Nobody should get confused in it. Yes, 2n factorial. Yes. So what I will do, try to understand. See, 2n factorial and 2n plus of 2 factorial can be smashed out. How? Try to understand. 2n plus 2 factorial can be written as 2n plus 2, 2n plus 1, and thereafter 2n into 2n minus 1, or put together 2n plus 2 factorial can be written as 2n plus 2, 2n plus 1, and thereafter 2n factorial. Everybody is agreeing on it? Everybody is agreeing on it, no? Obviously. So here, if we'll divide them together, if you want, so we can write it over here, is going to be n plus 1 factorial, n plus 1 factorial, n plus 1 factorial, and at denominator, here it would become n factorial, and here it would become just 2n plus 2 into 2n plus 1. 2n plus 1. Agreed? Agreed. What I'll do next? See, n plus 1 factorial can be written as n plus 1 into n factorial. So here it would just become yes. Tell me what would be the answer out of this. Let me go down. I do not have any space now. So here it becomes n plus 1. Tell me what's the answer we are getting. Sir, it's denominator, it. Okay. Get the answer out of this. Get the answer out of this. And that would be your answer. So now this problem goes to you guys. End of the day, I cannot go beyond because this complete outcome will get vanished because I am working over the PDF, so I do not have much space on it. So what you will do, at last, whatever the result comes over here, you will feed limit n tends to infinity. If the value became greater than 1, it would diverge, and if it is lesser than 1, it would converge. I do not have much space left out with this, but still you should have the clear-cut idea how to deal with the problem related to the factorial. So nobody should do like. Yes, 2n plus 2 factorial, nobody should write like factorial has been taken along with the 2n. No. It would become 2n plus 2 into 2n plus 1, and thereafter 2n factorial, this and this goes out. This and this goes out. Tell me what's the answer we are getting, because I do not have much space over here. Tell me what's the answer we are getting. So tell me how many number of students. Priyesh, you can say. Surajit, you can say what's the answer we are getting. Ambika, you can also reply what's the exact answer we are getting. That solely depends on the result. Tell me. Yes. So let me go down. And this problem have come in instrumentation, and again this problem has to get solved using the concept of what? Ratio test. Why? Because unnecessarily we have got some unknown terms along with the infinite term series. So what would be my basic intention? The problem has been clearly given. It's a series, obviously it's an infinite term series, has to converge. When it would converge, what must be the value of x? Must be the value of x? Again, I may not be left with the huge number of space, but still will try to coincide over here. So what I will do, see, first I would focus over the a of n. May I know what it is? Here instead the n, it is m. 1 upon 4 to the power of m, x minus 1 to the power of 2m. Yes sir, obviously yes sir. Now end of the day, you would be calculating a of m plus 1, which would become 1 upon 4 to the power of m plus 1, which could be written as 1 upon 4 into 4 to the power of m. And here goes x minus 1 to the power of 2. M would get replaced with the m plus 1, and here it would become 2m plus 2. 2m plus 2. Everybody would agree on that? Now, if you do the calculation, limit m tends to infinity, a of m plus 1 divided by of a of m. A of m, the value has to be lesser than 1, and value should be lesser than 1 because it has been made sure the result must be convergent in nature. There is no doubt in it, the value has to be lesser than 1. That means this is your requirement. So far, it was being asked whether would it be a convergent or divergent, but now it has been clearly given it is a convergent. Then I want to have the range of x. Yes. So a of m plus 1, what it is? It is 1 upon 4, 4 to the power of m, x minus 1 to the power of 2m plus 2. Yes. Here goes, or here comes 1 upon 4 to the power of m, x minus 1 to the power of 2m. Yes. So here it becomes limit m tends to infinity, and I need to check the value of x for which this limit has to be less than 1. So the common data has to be knocked off. 1 upon 4 to the power of m, 1 upon 4 to the power of m would be left out. Similarly, x minus 1 to the power of 2m and similarly x minus 1 to the power of 2m can be knocked off. So the data which have been left out is simply going to be limit m tends to infinity, the data which has been left with this term is going to be x minus 1 to the power of 2. Everybody would agree on that. And similarly, what about next? 1 upon 4. 1 upon 4. 1 upon 4. Yes. And this value has to be lesser than 1. This value has to be lesser than 1. This value has to be lesser than 1. But as far as the limit is concerned, this function does not carry any of the term of m. So as such, you can simply write this as 1 upon 4 is 1, or you can say has to be lesser than 4, has to be lesser than 4. So may I know what would be the range? What would be the range? Just try to understand, See, if you are taking x is equals to 3, so here it becomes 3 minus 1 to the power of 2, it becomes equals to a 4. But if you go beyond 3, if you go beyond x is equals to of 3, what will happen? This equation will not be true. So the upper range of x is plus 3. And similarly, if you go towards the left hand side, if you have come to the x is equals to of minus 2 minus 1, that would become, if you have come to the minus 1, so minus 1 would become minus 2 to the power of 2 would become 4. And that means if you go lower than the value of minus 1, what will happen? This equation will never be true. So as far as the range is concerned, the value of x has to be in between minus 1 to 3. You can take 0, you can take 1, you can take 2, you can take 2.9, you can take minus 1.01. In all of the cases, this would be a true condition. Otherwise, it would be just opposite. So what's going to be the best most answer? So the best most answer is going to be option number B. Yes. And still you guys are finding any problem in mathematics, you can put the comment over the comment box so that in future I may take the class for that particular doubt also. Otherwise, this would be my last class of the engineering mathematics. That means the crash course on GATE Academy Global is finished from our side. If still you guys are having any doubt, maybe technical or non-technical, you can put it over the chat box. I may consider to take a separate video on that particular topic. But within 15 to 20 seconds, you had to give the reply. Within the 15 to 20 seconds, you had to give the reply. And one more important thing, in my Telegram group, you try to post as many as number of doubts you can have. Whenever I get the time, definitely I would reply with the proper solution. Tell me. So hopefully I can assume that the studies are going well from your side, and I would suggest one more thing, at least on engineering mathematics and aptitude, focus the most, because this is only the two topic from where the highest weightage has been predefined and from where the weightage has been predefined. See, if you go into your core subjects, no, the weightage is not predefined. Sometime weightage goes up, sometime weightage comes down. But whereas the aptitude and mathematics is concerned, whereas Green's theorem is already done, the Green's theorem is already done, Stokes' theorem is already done in the great detail. What Green's theorem is done, dear? That is what I am saying. Concept through the question, I took the two different kinds of the question, and from that question I derived the Green's theorem. Green's theorem is the limiting case of the Stokes' theorem. There should not be any existence of the Green's theorem if there is not existence of the Stokes' theorem. I have taken that in Probably vector calculus, yes. In vector calculus, when I was taking or when I was understanding the concept through the question, even I derived the concept of Green's theorem using the Stokes theorem, and probably 2 or 3 number of problems were taken from the Green's theorem. Tell me, anything else? So the 2 input have come, Green's theorem and Stokes theorem from Prius as well as Ambika. That has been clearly done from my side. And you had to just focus over the probably vector calculus part. You had to focus over the vector calculus part. You need not to read anything more apart from the concept which I have taught in that video. Anything else? Okay then. I think we had a great duration, we had the great interaction, and probably you guys could have found my way of teaching bit fruitful and which will help you a lot in GATE examination. Is that part clear? Thank you then. We'll meet probably in the next video and with the next subject. Thank you very much.